In today's video, I'm going to show you how to integrate expressions in this form where we've got ax plus b to the power n, and I'm going to look at two cases. The first case we'll do is we'll look at when n is all integers apart from -1. Could be rational numbers as well. And then the second case is, well, what happens when the power n is -1? So in order to do this, the first thing I'm going to do is apply the chain rule. I'm going to look at a slightly different expression to begin with. So I'm going to actually differentiate ax plus b to the power n plus 1. Now when we differentiate, we can see I can apply the chain rule. I can pull down that power, subtract 1 from the power, and then multiply it by the derivative of that bracket, which would be a. So the derivative of that becomes a bracket n plus 1 multiplied by ax plus b to the power n. And actually what I'm going to do is formulate. I'm going to now reverse this. I'm now going to integrate this, and I'm going to have a look at some and remind myself of some integration laws that we have already learned. One of those is that any constants can be pulled outside the integral. Well, n is a constant, just a number. A is a constant and n is a number, the number 1. So I can pull this outside the integral, giving me that I just want to integrate the expression ax plus b to the power n. Now actually this result here with respect to x is what I intend to show you in this video. So when I do that, I can now look at, well, what did I do up here? Can I pull together some kind of result? Well, I do know that, remember that this differentiated gives me that, so therefore this integrated will give me that plus the constant c. So I'm now going to write this result, because remember I'm just integrating this part, as this here, which is ax plus b to the power n plus 1 plus c. Now I've created a equation with this result. So what I can actually do is I can now take this here, this whole constant, this it's just a number, and I can just divide it. So I'm just left with what I want to integrate, which is the integral of ax plus b to the power n. So integral of ax plus b to the power n with respect to x becomes ax plus b to the power n plus 1, all divided by a bracket n plus 1 and plus c. And like I said, this is case number 1, where n is going to be any number but not equal to -1. So n cannot equal -1 with this expression here. So I'm actually going to use this rule here. So this is a really important rule. So write that down, put it in a bubble, and we're going to do some basic integrals using this with this case here. Alright, so I'm going to do a couple of examples. So I look at this and I need to integrate the expression 3x plus 1 to the power 5 with respect to x. Now I look at the power n and I notice that it is not equal to -1, so I can go ahead and use the rule that we've just formulated. So that rule says I take this expression and keep it as it is, so 3x plus 1. I raise the power by 1, 5 plus 1 is 6, and then I divide by the new power multiplied by the derivative of this bracket here, which is 3. So I'm going to divide by 3 times 6, which is 18, and then I must remember to plus the constant c. So therefore I get, tidying it up, 3x plus 1 all to the power 6 over 18 plus c. Then I move on to the second example. Well, the second example, the power again is not equal to -1, so I can therefore go and use that rule, which then gives me the expression 2x minus 1, increase the power by 1, takes me to -1, divided by that new power, which is -1, multiplied by the derivative of that bracket, which is 2, plus the c. Tidy that up again. I get a whole negative expression because it doesn't matter where that negative is. Just because it's on the denominator makes the whole fraction negative. So I end up with negative 2x minus 1 to the power -1 over 2. Now I'm actually going to because we understand what a negative power means, let me just write that plus c before I forget. I'm now going to reverse that. So actually this belongs on the denominator. So I end up getting -1, because the numerator, obviously this belongs on the denominator, must be 1, negative, so it's -1, over 2 out the front, 2x minus 1 to the power 1, which is just 1, so we don't need to write it, plus c. Now what I'm now going to do is, well, let's look at the case when n is not equal to, let's look at the case when n is equal to -1.